Today we will try to conclude on everything Access. I'll take you through querying, Microsoft queries, not too complex to understand. And after query, I think that's all about it. We will try to look at another system. Maybe we'll try to look at a purchases processing system, which is more business-like, or sales processing system. How we can look at the entities in that small system. It's a subsystem of the main accounting information system. We want to model that subsystem, maybe purchases processing system, sales processing system. You can use this idea of relational database to model almost every system that you find around yourself. But we will choose some business systems, and we try to see how we can model them into a database using Access. Your exam will be around such things, so you have to pay attention to them. And if you go to the internet, you can find what others are doing. You can draw some knowledge from what others are doing. Not all those things that they are doing may give you all the things you need to understand, but at least you can get something from here, something from there, and then you try to be merging them like that. That's how we learn. Okay, so I'll get back to you in about 3-4 minutes. Wait for me. Okay, welcome back. I was trying to get a database, sample database that is populated with a lot of data, because we will need something like that for you to clearly understand the concept of querying. But I couldn't find one, so let's all make use of the one we have designed. Let's make use of the one we have designed. Hello? Hello, class.
Yes.
Hello, sir.
Okay, so before we try and do the query, I want us to add few data into our database. At least for the students, when you open the student form, we have 3 records, and you can read the number of records from this small window here. You see 1 of 3, that tells you the total number of records, and you can click on this one to open a blank one to add someone. Let me quickly add just any name, simple name, first name. Who wants to give me a name to add?
Elsie.
LC. Okay, LC. Surname is
Annor.
ANNOR. Okay.
Yes, please.
Index number SB ACC 18
0125.
0125.
Yes, please.
Date of birth, I think it's not a required thing, so, and it is female because we made this one a default value. So
Yes,
enter. Let me open another one. Another simple name. First name Wendy. Wendy Ose. Wendy, is that your surname? Wendy Owusu?
Yes.
I think so. Wendy
Say
Owusu.
Owusu.
Okay, and let's add one more.
Edmond.
Okay, so it says I have to. Let me just enter anything here for date of birth. Index number. Wendy, give me your index number. SB
ACC
ACC 18
0235.
0235. Okay, I think you noticed something. I wanted to skip the index number. So when I was opening a blank form, because I had not entered any value in the index number field, it gave me a feedback. It says no, there must be a value inside the index number field.
Yeah.
And the reason is that we set this record. You have to understand that this form is interfacing the table. When we're doing the table design, this field called index number was set as a required field. So if you don't type anything here, it will not make you go until type something there. Okay, so let's be okay with the number of records. Let's assume that this is the total number of students. It would have been beautiful if you had a lot of records to do the query, but let's make do with it. Let's try to create a form. All of you can create a form now. So I'm assuming we have created a form. We didn't create one for the fee. So let me open the fee. I think we didn't even complete the fee table. That's so bad. Okay, so let me do, because I'll need to demonstrate something with some figures. All the tables we have created so far, predominantly they take text data. So let me do the fee so that we can use the values in there to demonstrate something. So let me call this fee ID. It should be auto number. Let's make the first field be fee payable. Fee payable, that's the amount you have to pay. And let's make this one fee paid. Okay, this is the amount you have paid. This is the amount you were supposed to pay. Let's make the data type, you can make it currency because you'll be dealing with currency. But one thing you have to be sure or be aware of is the fact that if you make it currency, it will automatically be formatted with dollar symbol. That's just a symbol for the currency data type. It doesn't mean you are trading in dollars per se. We can also make it currency. You can make it just number, so that you if you hate the idea of dollar coming with your figures, you can make it just number. It will be raw number, and then you can later format it. You can export the output into Excel and format it with your own currency symbol, like the Ghana cedi symbol. Okay, for now let's make it currency. That's it. We can, here you can do some other adjustment to the properties. Even here I think we have options under the format. you can come here. Yes, you see this one with comma separations, other ones without comma separations. Okay, you can even see other currency symbol. We have euro. We have, so that's the reason why I explained to you. So you see, this one is not made, is not said, is not labeled as dollar. It just said currency, and it has the dollar sign, because for this particular database, the dollar sign is a symbol for currency, not for dollar per se. But of course, if your currency is dollar, it works the same way. You can choose the first one, which is general number. General number. You can also choose this one, standard, with 2 decimal places for pesos. So maybe let's choose that one, so that it doesn't become like we are taking dollars. Yeah, I think everything here is okay. If you want to make some of, I think all of them should be required, because money is very important. So we can make all the 2 fields required fields. Once you set up a student, or you enter a record here in the fee table, all these records must have values. Okay, so that is it. We can save the table and then return to datasheet view. If we had created a form, then we would have used the form to enter the data here, but it will be time wasting for me to go and create a form. Anyway, we all know how to create a form, so let me enter the figure straight. Let's say the amount to pay, or we can even go back and set a default value for the amount payable. Default value. Normally for students, if it is one batch of students, say level 100 or level 200, they all pay the same fees largely. So in order not to type the same thing every now and then, you can set a default value for it, so that you only change that value in the few instances where it varies. That saves you time, and it also ensures accuracy in the data entry. So let's say it is 2000 as the default value for fee payable. Okay. Alright, so now let's enter the record. So record 1, and of course fee must be paid by a student. It's just an automatic connection between the student table. I hope you can all see that. A fee cannot stand alone without any connection to a payer. So that tells you that the fee table has automatic relationship with the student, because the students are the people who pay the fees. So we have to do a relationship between the fee table and the student table. So to do that, we can place the foreign key here. Let's go to design view. We can place the foreign key here. The foreign key here will be just a copy of the primary key of the student table, which is student. But it doesn't really matter the name, so I'm going to make it student, but I'm going to do the linking with student. The database can make you, this is what is more friendly to you, a human being, student. Okay, so let me just do a lookup and do the linking between the 2 tables. I want to look up fields from other tables. Of course, that's what I want to do. And the table is the student table, and the field is student, right? The field is student. And I can bring the student's index number along, so that I can use the index number to assign, but the system will use the student ID that comes with it to do the relationship. That's how we do it. So let me go forward. Okay, because I have added a field that is user friendly, the database automatically hides the key column, because the key column is actually meant for the computer. So I will be using this one. If you think even the index numbers are not too good for you, you could have put the first and second name, but those ones are not too intelligent, because you can have 2 students or even more students with the same surname and first names. That can be conflicting. So the index number is good. So let's go enable data integrity, and then we say finish. Okay, so the relationship is created. When you go to the relationship window, you can see that a new relationship, and you refresh, you can see the new relationship. Right, so when I go back here, I'm now entering the data. So I now can enter, let's say this fee, the amount paid is at 1,000. All right, and I have to assign this payment to a student. Of course, we can even add a column to this. We need to add 1 column to it at least. That will be called receipts or payment receipts as evidence of payment, and that field will be an attachment field. So we can scan and attach the person's receipt. So let's say this fee is paid by index number 235, and you have to know the index numbers. And if you think that is also troublesome for you, you can go and adjust your lookup to add the names along with the index numbers, so you can cross check. This is for Wendy 235. Is that correct?
Yes.
And of course, even on the receipts, you will find the student's index number. So when you type the amount payable, the amount paid, you can know from which student, because here in the university we deal more with the registration numbers than names. So I assign this payment to this student. Let me save. Let me go and update the records here. Let me add one more field called receipts. That's a very important information not to skip. Receipts. So receipts will be attachment data type. Not really a data type, but that's a flexible way Access makes you attach things. So attachment, that means you can attach the receipt, the scanned receipt or any picture of it to the database. Alright, so when I save and then come back to datasheet view, you will see that attachment is here. When you click on the attachment, you will realize now it is 0. Okay, but I can really attach a document to it. This thing normally behaves not too intelligently. Let me come. So let's add another student. Let's say this is this student pays 2,000. He pays 4 payments, and what's the name? Let's just assign as if we know that from the receipt the person who is this is number 5. This guy, he pays it. We can attach. This then behaves sometimes not too intelligently. If we were using a form, if we had embedded a form to this table, we would have been very easier attaching from here, because of course when you click here, it's supposed to bring you this window. Yeah, so when you click on the attachment field or column here, this is what you will see is actually asking you, where can I find that material you want to attach. Let me try to direct it to some locations on my computer if we can get something that is attachable. Let me go to my pictures. I don't think I have any pictures that I can. Not really. Downloads. Don't have. Okay, so let's assume, it's just for example, that this one is the scanned receipt of the student. So I have located it. It could be on a pen drive, it could be on your computer. Maybe your scanner is attached to your computer directly, so when you scan, it goes to a certain folder. Let's assume that is the folder, and this is the scanned receipt. You just click on it and you say okay. So it will come, it's here. Then you can just say okay like this. it will attach it. So you see attachment 1. You can attach quite a number of files to the same person. So let's say, okay, this one too, I think we have to attach. So let's try to do something practical. So let's attach this to represent receipts. This guy also has paid, let's say, 1,500, and then the student who did that payment is this guy. Attachment. Okay, so that is okay. You would have designed a form to do this when I'm doing. I explained to you that it's just for time reason that I'm doing it directly. So you have input records into the fee table. You have done the relationship. Okay, so now let's talk about queries. Query simply means asking or requesting the database to give you what you have said you want, what you have instructed the database. So it works like this. If you tell him to go and pick something from the fridge, you have to define exactly what is inside the fridge that he has to bring. You do not expect that if you ask the database to go and you send someone to go and bring something in the fridge, and the thing is actually not in the fridge, but it was inside some cupboard. I mean, databases, computers are robots. They don't have that kind of thing that human beings, that ability that we have. I can understand as a human being that, oh, I've searched through the fridge, it's not there. I was never told that I should look through the cupboard to check if it is there, but I can guess, oh, maybe it's in the cupboard, let me check. Or if even we have 2 fridges, I can understand that, oh, if it is not in this one, let me check if it is in the other one. I was never given the instruction that if it is not in the first one, I should check the second one, but I can do that. Computers can't do that. Unless everything you want them to do, you have to tell them. If you don't tell them, they don't know. Yeah. So in querying, you have to be very specific in whatever you want the database to do. Let's do a simple query. Query, if you come to the Create tab, you'll see the query group. Where is query group? Actually, we have only 2 of them: query design, query wizard. We'll be using the design because we want to learn how to do things from scratch. As for later, you can learn how these things are. This one, you don't even do anything. The software actually guides you this. That's not learning, so let's do it. When you click on the query design, this is what you see for the first time. Okay, so this is the design grid. Here you can even do some computations. You can set some sorting criteria. You can do a few other things. And the top part shows you the tables. That this one shows you all the tables in our database that you may draw information from. Okay, so if I want to get information, some simple information like all students, so I can double click to bring the students table here. I am now asking the database questions. In fact, in the main language for this thing we are learning, relational database, is what we call the structured query language, SQL. Structured query. I think most of you might have heard of this, and it is, the short form is this: SQL, and some people pronounce it in some fast form SQL. Whether it's SQL or it's SQL, this is what it is: structured query language, and it is coding, but it's a very friendly coding. The codes mimic the English language. So if you know how to speak English, if you know how to write English, you can easily learn this language. Alright, But the access version of it is the click type. That is what we are doing. That's what your course says. So if you want to take this knowledge of database design to some level, and it is good for you accounting students, because that is the way accounting is going now. Accounting is becoming software. It is no more the big books that you write. No. Accounting is now computer work. So you have to learn how to use the computer. You have to learn how to even automate the things that we have been writing in books. If you don't learn how to do those things, you will go jobless. That's the fact. Right? So if you want to actually take this is just like intro to what is happening in the world of accounting and finance. And you get your appetite wet with this. If you want to take it to some good level, learning SQL is not too difficult. You can learn Microsoft SQL. You can learn it with Oracle. You can learn. There are a lot of you can learn it with IBM. A lot of variants of that language. And any one of them you learn is like you have learned all of them. And it's a standardized language. In fact, they even have an ISO on it, International Standards Organization. They have structured standards on how you have to do your software to align with the structure. So you can learn one and it's like you know all of them. Okay, so we are doing Access. We are not doing SQL, Oracle, whatever. So now this is the table. This is the table you want to draw the information from. So it's like you are asking the database a question. So from this table, show me first name of students, surname of students, their index numbers. That's all I need. So I am double clicking on these fields here, and they are dropping into the query design grid, the lower part. Of course, I can make this one a little bigger here. Okay, they are dropping into it. So it's saying that it understands it this way. Okay, you want first name of the student to show, so you can see the field that is drawing. It is picking the report that you want to be built from. That's what you see as the field. So the field names are first name field, surname field, index number field, and then the table is student. That's how it will show you. If you want to do sorting, so you have the sort here. You can sort on the first name in ascending, descending order. And then this one tells you that all of these things will show in your report. You have the choice of bringing them in the querying but not showing in the final report. Sometimes some people like it that I will sort the records on index number basis in ascending, but I'm not that much interested in the index number, so I can hide it even though the sorting is based on the index number. I don't want it to be shown in my report. In that case, you may uncheck the checkbox. And then criteria, in fact, that is the main subject that we'll be talking about when we are doing querying. And we talk about different levels of criteria. You can set criteria for the report to be dynamically generated just anyhow you want it. But for now, let's see just how it is. Let's say we want this simple report. Because we never added the date of birth and the gender, we don't need that report, so it's just what we need. Then you can click on datasheet view, you can click on run. So run. So it goes through the database and it sifts through that table or those tables. You can combine tables and picks just what you said it should bring. So you said it should bring first name, surname, index number. That's what it brought. If you had said something else, it will show that. It will show just that. I can go back. You can go back and redesign. So I can say, okay, I rather want you to add gender to this, and then go to run. Okay, so it will add the gender to it. Okay, so the report can be as simple as I've demonstrated, or it can be highly complex where you are combining, picking the information from several tables. Let's go back again. Now let's say we want to do students and the fees they have paid. In that case, I have to bring the fee table along. Okay, and then you'll see the relationship right here between them if you have done all of them right. So I want to know this. So I can remove, let me remove I want to build a report that shows the first name, surname, index number, and the fees that they have paid. So let me remove this one, the gender. Alright, so instead of the gender, I will now want this record to be added to this. I want the fee paid from each student. Okay, and now this brings us to something we call joins. When I right click on the relationship line here in the query design, when I right click on it, you will see this small dialog, and the first option is join properties. When I click on it, you will see the join properties dialog box fully open like this. And then we have three main join types. The first one is the first type of join says only include rows where the join fields from both tables are equal. This is what it means. When I run, it will have to show me records of students who have paid fees. If you take the first option, it will only show students who have paid fees, or it will show records where there is a student and that student has paid fees. So it will drop all students who don't have fees paid for them. In other words, it will drop all students who do not have a related record in the fee table. That is the first join. And I'm giving you a reading assignment. You can put it somewhere. There are specific names for these three types of joins: left join, right join, equal join. Go and read and know the name for this first one, whether it is a right join or it is a left join or it is whatever join. For the second one, go and know the name for it. That one is a simple thing. You can even do it as you are listening to me. Okay, so that's the first one. It will show, let me drop this and let's run. Okay, so it's showing you three records, right? Because the first join type says bring me report where we have students and related fee information from the two tables. So if we have even 1,000 students but only 3 of them have a matching record in the fee table, it will show only the 3 and drop the rest. So it depends on what you want to show. So let's say we don't want it that way. We want all of the students to show whether they have paid fees or not. It means we have to come and pick the right join. So the second one says include all records from students and only those records from fee where the joined fields are equal. In other words, it's saying that for the student type, I want to see everybody whether they have paid fees or not. But for the fee part, I want to see only those who have paid fees. So it will show all students whether they have paid fees or not. That's what it will do. So when we choose this option and we go back to OK and run, you will see that the records will be different. The first one, we just had 3 records. Now we have 1, 2, 3, 4, 5. So it's showing these other 2 students, Prince and Elsie. They have not paid any fees, or we have not entered their fees in the fee table. Okay, so that's what you have to know about joins and the join types. The third one is the opposite of just the one I just talked about, where all the records in the fee side are shown, but for the student side, we show only students that have a related fee. In this case, that is not logical. In some other design, that may be logical, but for experimental purposes, let's see how that report will be like. So it shows the same 3. Yeah. Any questions so far? Hello class, hope you are not sleeping. Hope you have not left me. Are you there?
Yes.
Okay, so any questions so far?
Please, with the when you were doing the relationship between the students and then you didn't do the normal relationship, but you used the lookup. I think that can you go over again?
Okay, is that LC? Is that LC? Okay, I want to know first whether you know how to do relationship through lookup.
Yeah.
So it means you can do that relationship because that's what I did. I did it through lookup.
So you clicked on a certain. You didn't do the normal one that we were doing. You
I
did
did the
something.
normal one. When you go home, do it the normal one. You know it will be the same thing. I did a normal one. Maybe you were not paying attention. It's a normal one. You create the foreign. The foreign key is in the foreign key is in the fee table. So the foreign the foreign key is the student ID. So the student ID is being used to link the 2 tables, but we don't want to see the student IDs to be 1, 2, 3 numbers. We want to see the index numbers. So for you, the human, you will see the index numbers of the students, but the computer is using the student IDs that are 1, 2, 3 to connect the 2 tables. So I did it the same way. Yeah. Any other question?
All right, thank you.
Another question? Okay, no other question. Let's proceed.
Yes, I have a question.
Okay.
With the joint properties, no. So where those who have paid their fees appeared and those who haven't also appeared now, I didn't get it now.
Okay.
Which of them is it like to display that?
Okay, so this is what I said. So let's click on the relationship line. We will see joint properties. So this is the joint properties. Can you see I can enlarge this window, but I hope you are seeing.
Yes, sir.
Good. You will see these 3 types of joins. One with radio buttons. 1, 2, 3. Right? Can you see that?
Yes, sir. Yes.
Okay, and then you can see left column name, right column name. So the join property, you are joining two tables, right? Into in producing a report. You are picking information from here and adding. You are joining 2 tables in designing your report. So you'll pick some from here and pick some from here. But the next question becomes, okay, I have students in the student table, in the left table, and then fees. You know, it is possible that I can enter all my students. We can even enroll all students before we enter their fee payments into the system. Some time ago, that was what the university was doing. So you could be registered, and I think it's still going on with the regular students. Yes, because you can register, especially when it is in the second semester. Some people don't pay fully their fees. So they pay partly for the first semester, they register. In the second semester, I don't know exactly how it works, but some systems can allow you to register into the second semester, and then they later go and show their school fees receipt for their payment records to be updated. In that case, we can have a lot of students in the student table who do not have any records in the fee table. because we are yet to update their fee status. So when we want to show students and the fees they have paid, there are some of them that may not have any fee payment. So how do you want to show the information? Do you want to show just students who have paid fees, so that we have for every student there is fee before him? That is the first type of join. Only include rows where the join fields from both tables are equal. That's the first type of join. Or I want to see all the students, whether they have their fees entered or not. In that case, it's possible you can see more students than fee, more records for the student table than from the fee table, because there are some students that will be pulled from the student table, but they don't have a related record in the fee table. I don't know if you are getting me. That is if you choose the second option. It will make you see all the records in the left table. This is the left table. That's the student table. All records there. But here, when it comes to the right table, it will show the records. It will show the total records that are here, but you have to understand that there are some students who have not paid fees, and those ones will not show any records. So you have more, the number here will be more than here. If you don't want it that way, but in school management, that may be more logical to do. I want to see all my students, those who have paid fees, and even those who have not paid fees. That will make you even see those who have not paid fees, or those whose fees have not been updated. So in that case, the second join will do. Include all records from the student table, and only those records from fee where the join fields are equal. That is it. You have to go and read a little bit about it. So that's it. The third join is the opposite of the second join, where I show all the records here, but all the records in the fees, whether that fee has been related to a student or not. That logic comes from where we have a system that we can enter all our fees without relating it to a student, and then we later go and relate to a student. In this particular design, that is not possible. We cannot enter fees without knowing which student it is for. So the third property, join property, doesn't work here. But I explain it because you have to understand. In some design, the third property may be the appropriate property to choose when you are doing your reporting. Ours is this, second one. So when we do this, you will see all of our students paid fees or haven't paid fees, like this. So you can know, okay, this is a question mark, this is a question mark. Have they really not paid, or they have paid and we are yet to update their status? And you can even do, you can enter, the amount here if you find it here, or you can go back to the table and then you can do that. Are you okay?
Yes, sir.
Okay. Any other question?
No, sir.
Okay. So let's go ahead. You can also set criteria. Apart from sorting, it's very simple to do. So you can sort. For example, we have sorted all the records that will show in our query. We have sorted it on the index number ascending. So when I do this, it means that all of these people are sorted. Prince Hagen, we have sorted them on index number, and then you can see it 27 125 146 23, and then see this, because this is a little different from this. So that's why it is here. We have sorted them, I think, ascending. If you want to change the sorting criteria, you can come and say, okay, delete this kind of thing from here, no sorting. I actually want to do the sorting on first name, maybe descending. When you run it, will just do that. First name descending, then Wendy has to be the first person. So that is simply about sorting. And criteria, if I want to set criteria, in fact, that's the main subject we'll be talking about in query. we have different levels of criteria that you can set, depending on whether the field that you are setting the criteria on. In fact, the field for this one where I am now is the first name. If you are setting the criteria on the fee paid, which is a numeric field, we have different. If it is a date, we have a lot of formulas. Most of them come like a formulas or codes, but they are very logical. Then it can do the sorting, the criteria for you. The criteria is also a sorting sort of thing, where you can build complex criteria for the sorting. Yes, please. So, for example, hello? Were you speaking to me? Hello? Hello? Hello, student, can I go on?
Yes, sir.
Okay, so let's say I want to set a criteria under the first name. The criteria can be, maybe I'm looking for a particular student. We are dealing with a lot of students, like all UCC students. But I'm looking for a student whose first name is Elsie. So if I know Elsie, I can just come and type it here. So Elsie, let's see. But if it is a text, coding requires that we put it in quotation. In quotation. But sometimes if you don't put it in a quotation, the database already knows that this is a text field. So any criteria you build there should be text. So it can put the quotation for you. So when I click outside, you see the quotations are there. I don't see how I can zoom in on this, but I hope you are seeing it. Are you? Are you? Okay, so I have set a criteria. I want you to do this report, but the criteria based on which the information should be that the first name of the person should be Elsie. In fact, you may build this criteria if you are searching for someone whose name is Elsie, or people whose names are Elsie. When you do run, it will go through it and find that person. So that's criteria. So you are seeing only one record because there's only one Elsie here. And basically this is how text criteria is built. This is how text criteria is built. And you can do combinations of criteria, but you have to look at the complexities that can come in when you are doing that. So simply, this is a test criteria. You can also set a criteria on the surname, whatever it is. But let's come to numeric criteria. Okay, I think I have to say something last on the test criteria. It could also be that, this one I said, I know that the first name of the person is Elsie. I know the exact surname. There are instances that you may not even know the surname, but you know something about it. You know, okay, that name begins with maybe E, or it begins with S, or it begins with Q, whatever it is. I know it. I know what it begins with. So you can use the idea of what it begins with to search. And it will bring you records that begin with all that kind of thing you have specified. Then you can sift through it and find it. So let's see how we do that one. That one, you use a keyword called like. I mean, normal English word like. In other words, you are saying that, oh, I'm looking for something that looks like. You don't know exactly how it looks like. Okay? So you don't know exactly how it is, but it looks like something. So you just use this. So let's say like. Okay? Like, because like is the keyword, you don't put it in quotation. So like E. And so this is the code for where you know it begins with this. I know it begins with E, but I don't know what follows the E. So it begins with E and something, and that something is specified with asterisk. So E asterisk. So like E asterisk, it means that it begins with E. That's all I know. And what follows can be just anything. Okay, so let's run and see. Okay, so it goes and look through the whole of the tables that you have used in building the query. It goes through all of them, looking for the words that begin with E. And there's only one, Elsie. If you come back and say, okay, it's like, I don't know whether we did S, but it's like S. Let's try to do that. I don't know whether the people we put inside, any one of them's name begin with S. So nothing. It means there's no one whose name begins with S. Do you remember some of the names?
Right.
So P. So I know, okay, it begins with P, but I don't know what follows next. So let's run. Okay, so it will bring Prince. Right, so that's about something also to be added to this text field criteria. And then it can be, let's say you are looking for you can also know about the end, because if you know about the beginning, and you can use that trick to find, okay, I know that it begins with P, so go through the records, bring everything that begins with P. It will show all of them. In this particular design, if you have about 100 records beginning with P, it would have shown all the 100. It's just unfortunate that we have only one, so it's showing the one. So let's see where we know about how it ends, but we don't know anything else. We know how it ends, the ending words. So in that case, you can say, you just reverse this. This is P, then asterisk. So when you reverse it and say asterisk first, and then P, you are saying that you don't know how it begins, but you know it ends with P. Alright? So it's just a smart way of doing the first thing. Do you remember some of the letters that the first names end? Wendy ends with Y, so let's say it ends with Y. Okay, it ends with Y. So go. I know how it ends. It ends with Y. That's all I know. But go and find anything that ends with Y. Okay. So if there are thousands of those things, it will show all of them here. And it also works the same way. Maybe you don't know only the beginning, only one letter. You know some combinations of letters. You don't know only one ending letter. Maybe you know a combination of them. I know it ends with dy, for example, dy. So you just do it like that. I know it ends with dy. Not only one letter. It can be a combination of letters ending or beginning. I know it ends with dy. It will bring you the same thing. So anything ending with dy. I know it begins with W, for example. Yes, it begins with W. It will go and find anything that begins with W. I know it begins with WEN. It will just find that. It will just go and bring all of those things. Any questions? It means the reverse is also true. The like keyword, the reverse form of it is not like. So I want to see everything except what doesn't look like this. I want to see everything except first names that don't begin with WEN. That's why you use the not like, but that is not, really used. If I know the like, then I can find what it is like than what it is not like. But that is also there. Not like, so now let me add not to this. Not like when. It means that it will bring all the records which do not begin with when, because we don't want anything that looks like beginning with when. Now let's run. So it has to show everything but drop Wendy. Are you okay? Are you following?
Yeah.
You are following, right?
Yes, please.
Yes,
That's
sir.
that's good.
Yes, sir.
Yeah. So that's how like and not like are used. They are opposites of themselves. So not like when it means I want to see everything, but not something beginning with W-E-N. So it means anything that begins with W-E-N should be dropped. I want to see any other thing not like this. Yes, that's the meaning. Let's talk about let's also talk about this on texts criteria. Sometimes, just like I said earlier, I know the beginning part of the first name in our case. That's all I know. I don't know anything about the name again. So help me find it. Database, help me find it. So that's your command to the database. Database should go wherever it should go to find the results for you. But in practice, you may have a range, or you may want to do a record where, okay, I want to see all first names, or maybe all countries, not only first name, maybe all countries whose names begin with whose beginning the letters that begin their names fall within the region A to D. So America, Britain, Canada, between A and D, all of countries whose beginning letters fall within A and D. Show me. In our case, we are using first name, so you can do that. In that case, we are using the same like because we don't know the exact thing. So like, and then we have, you use this square brackets to put that range. So if it is beginning A to D, and this is how you use the two, A to D. Appropriately, you have to use the uppercase, but it is not case sensitive anyway. So the lowercase will still do. And you have to be, because this is text, you have to put this one in quotes like this, in quotes like this. Okay, but the database can sometimes guess even if you miss it. So now let's run. What we are commanding it to do for us is search all first names that begin with A or B or C or D, so between the range of A to D, and then run. None. That is strange. So all the names we typed, none of them begins with A, none begins with B, none begins with C, none begins with D. That's crazy. Okay, so now let's say between X and Z. Okay, and run. Hey, is that true? But there is Wendy. Okay, that is outside. W is outside here. So let's say between W, let's try to see if it is guessing things right. Between W, at least we know that one person begins with W. So between W and Z, and let's run. Okay, no, something might be wrong.
I think you said
Exactly. What is?
So W.
No, it's what is? There is something missing with our code. We said the name begins. The range of the letters that the name begins with should be W to. Let's all make it. Let's say W to Z.
Oh.
Okay. but we don't know whatever follows. So we should have brought the asterisk here. The asterisk here means that it begins with what is in the square bracket, but something else follows it, which we don't know. So all those things that follow it that we don't know is represented by the asterisk. The command I typed first, I omitted the asterisk. That is why it didn't give us the right result. So let's run again. Okay, so now it goes through the database, and between the range of W and Z, the names that we have, there is only one person that falls within the range. Let me do the first one we did again, A to D, and see if we have that. And if you build your criteria correctly, the database doesn't make mistakes at all about that. It will always give you the right thing. Okay, so A to Z, we don't have anything there. We don't have anybody entered so far whose name begins with A or B or C or D. Nobody. That's what the database is telling us. All right, so that's how you build that kind of criteria. I want names that begin from A to D. Bring me anybody whose name begins with A or B or C or D. Let me see them. Maybe you are searching for something. That's how you build those criteria. Alright, so let's talk a few things about number. So the number, it means that the criteria will come to the fee. So the fee here may be the criteria. You want to see all students who has paid maybe more than 1,000. So you can do greater than 1,000 here under the fee paid, who have paid fees more than 1,000, and then you run. It will show all of such students, and then you can see them. It's Josh Apia, and Josh Ado. They are the only students who have paid fees more than 1,000. The rest have paid fees below 1,000, and you are seeing them right there. And you can see maybe greater than, right? Greater than or equal to. Greater than or equal to. And this is how we do it. We don't have those fancy characters on calculators. So we use just what we have on the keyboard. So this is how we do greater than or equal to on the computer. You just use the two symbols, greater than or equal to. In this case, it will have to bring students who have paid fees from 1,000 to the upper limit. So let's run. Now we have one more student being added. Wendy has paid 1,000. So that's how you build criteria. If you want to say that I want students whose fees is just this, or I mean, in this case, less than or equal to those inequalities. You can also say equal to. So you want an exact thing. Equal to 1,000. In that case, it has to be just equal to 1,000. If it is more, it won't return it. If it is less, it won't return it. And there's only one person whose fees is exactly equal to 1,000. Okay, so that's it. Any question? I hope everything is okay. Is everything okay?
Sir, question.
Okay, question. Quick one.
Sir, can you have a query on the names of students within, let's say, A to D, and as well as their last names too, from maybe D to S, and then the C page, like all at the same time?
Yes, you can have criteria set on all the fields. But the question is the criteria you are building sensible? For example, if you want students whose names begin with the letters A to D, how is that also possible to find, to merge that one with their surnames also beginning with this? That may be conflicting. So you make sure that the criteria you are building, well, the computer can take almost criteria under all the fields, but the question is, are your criteria not conflicting? First names beginning from A to D, that's okay. Any name that begins from A to D, that's okay. There may be another time a surname beginning or ending with this. But if you say first name beginning A to D and surname beginning A to D, for example, some of these things can be conflicting. it can find a surname that begins within the range of A to D, but it doesn't meet the surname criteria ending A to D. In that case, it's my report on the basis of your first criteria and drop the other one. So you don't set those conflicting criteria for the computer. What you said is just like sending the computer to Accra, and the same time that the computer should go to Accra, it also has to be in Kumasi. That is not possible, because you can be here at one time and move from there to another time. You can't divide yourself. So when you are setting your criteria, you have to be careful about those things. So you can do what we said, okay, maybe like W. So all students whose first names begin with W, for example, and whose fees is equal to 1,000. So if they meet, if the two criteria meet, it will only report where the two criteria meet. If they don't meet, then it will drop them. So if I say begins with W and something else, okay, that's criteria. But let's say I do greater than 1,000. From the little records we have in our database, we know that there is only one person whose first name begins with W, that's Wendy. And Wendy's fee is not greater than 1,000. So you will not see any record returning. Well, the criteria is correct, but it will search through the database to find where that criteria finds a match. If it doesn't find a match, it returns to you that there is no match. So it will only show a record where you say is equal to 1,000 because its fee is 1,000, or you say less than or equal to 1,000. In that case, it will find a match. Are you okay?
Yes, sir.
Okay.
Yes.
So if we can do this, equal to, less than, greater than, less than or equal to, greater than or equal to, it means we can also bring the keyword not. So for example, if I say 1,000, if I just type 1,000 here, it will show all, let me remove this criteria. It will show all students whose fees is 1,000, and then we may find only one person whose fees is 1,000. I can add this keyword not. So you have to find some of the keywords. Not 1,000. So not 1,000 is that I'm excluding the 1,000. So show me everything but not 1,000. So you see this. So that's another way to search for information. So I think basically the rest is something you can read and understand on yourself. I'll attach the information on criteria building. I've converted it to PDF. I'll attach it there for you to learn the rest. But basically these are the things you have to know when you are doing query designs. If you have questions for me, I'm ready for them in maximum 10 minutes. Questions? Do I have questions to answer?
Hello, Dave.
Yes,
Hello,
please.
sir.
Hello, Dave.
Please, your name first. Mention your name.
This is Malinda.
Yeah, Malinda, let me hear you.
So, please, when we started, we were like, with queries, we have query design. I didn't get the second part of the
Query wizard.
type.
Are you working with a computer right now?
Those days.
These things is ideal that you will be where you have your computer before you, where you have even opened your access. You cannot, for these things, you cannot learn them and store them in fridge, in quotes, and then you later go and use them. You have to be eating it because it will expire. You see, these things that involve practice coding things, the best way to understand them is do them. That's the best way to learn them. Do them. If you listen and you want to later go and do, you may get corrupt somewhere. So if you had a computer, you wouldn't even have asked this question. You would have gone to the Create tab and look at the Query group. You will see just two buttons here: Query Wizard and Query Design. A Query Wizard is just like any wizard. It just takes you step by step. So next, you go to next, and it gets it done. You just change your options, next, change your options, next. That's what it does. So you can go and see how it works yourself. But this is the real deal because we are learning. That's why we came to the Query Design. Melinda, are you okay?
Okay, sir. Yes, sir. Thank you.
Yeah. All right. So if we don't have any questions, I want to introduce the last thing we'll be talking about. In fact, we have concluded everything on Access. This group, the reports group, is your job. This is programming. If you're interested, and it has some learning curve, learning Visual Basic, you have to learn the codes. And I told you that computer language is just like any natural language. I am not a Ga, so if I want to begin speaking Ga, I have to go for the Ga characters, the letters, how we pronounce them, how we combine them in twos to form words, blah 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 blah. That is just how computer language is like. So you can learn Visual Basic, which gives that automation to the applications you will build. Yeah. So you have this reporting thing to experiment with yourself. So I'm done with Access. What we are going to do is more like a tutorial. We have built an Access database for a school system. I want us to go and read on how to build an Access database on one. So you can put it somewhere. One. Sorry. On one. Purchases processing system. Let me give a brief overview of it. There is a standard processes that if a typical business organization wants to buy goods, it goes through. And we can model that small system into a database. This is what, you are accounting students, so you can even teach me. So who can teach us how the purchases processing system works in a business? 2 marks if you are correct. Two marks, 2 marks is available. Don't you like it?
So let's go and do it first. If you are
Okay, so let me give you the overview.
The question.
I said someone should give us an overview of how the purchases processing system in a typical business organization works, how it looks like, the processes, the procedures. Quickly, let me give you the overview. You can go and read, and we come and attempt designing one with Access. Of course, you know that if the organization, let's say, if the organization is a very big organization, the various parts of the organization, they may have a centralized purchasing department. In the university, for example, university is very big, so you have procurement office. That is equivalent to a business organization's purchasing department or purchase department. UCC's one is procurement department. It's the same thing. So if School of Business, or let's say Department of Accounting, Department of this, Department of that, if they all need things, they raise a requisition. They are requesting these things to be bought for them. They raise a requisition to the procurement department. You learned these things in level 100, didn't you? You did. I know you did. Your lecturer told me you did. Okay, so they will raise it to the procurement department or the purchases department. Then the purchases department, after compiling these things and summarizing them, adding what needs to be added, aggregating them, then they will now talk to suppliers. They might have an existing supplier list or vendors database, or there's a vendors information. Then they call the vendors. We need this. Do you have it in stock? Can you get it for us? Then they may take a phone and do the call, but in business we do not call by that means. We call by papers. We call by documentations. We communicate by documentation, which is what we call source documents. And you guys are good at those things. You know them already. So the procurement department or the purchasing department will raise what is called PO, purchase order, to be sent to the vendor or the supplier, requesting the supplier to supply. When the supplier supplies inventory. Let's say it's generally about inventory. The supplier supplies goods, products. So let's generally call them inventory. And then that kind of arrangement creates accounts payable. Because the standard business is that they supply them and then we pay them later. So it creates accounts payable. Creditors to be paid. Creditors will be paid. So that is the system. Let's say briefly, that's how the system works. We might have certain things in between them depending on the way the organization wants to do things, but this is generally how the system works. Purchases processing system. The opposite side of it is the sales processing system, where others are buying from us, we are selling. So it's the mirror image. So at least the things that we have talked about that can form the entities, the building blocks of the database, will be the purchase order, the vendors or the suppliers, and how they link with themselves. We have inventory, we have accounts payable. You can have a payments table which take tracks of any payments made that can be matched with the accounts payable for you to find your ending accounts payable that will go to the balance sheet and how much of the accounts payable has been settled into payments. So basically this is in brief how the system works. I've given you the overview. When you go and read, you already are accounting, so that you have a lot of accounting, good accounting books, and in fact you have done this thing, so you know better than me. Also look at the so second one is the sales processing system. Which people are calling themselves like that? Okay. So you have the assignment now, right? Hello?
No,
Hi.
Are you here or you are somewhere?
Yeah.
Okay, so did you hear the question? So these are the systems you should read on in terms of how we model them. First of all, in terms of how we break the system down into the entities and how we model them into Access database, right? Good. I'm also going to read on it. You also go and do that. We all come and then we look at it, then we conclude everything on Access. So this will be like a tutorial. We have actually ended Access. Our next, apart from this tutorial, then our next module will be on Excel. So you have to begin to sharpen your tools on Excel. Thank you very much for your attention.
Thank you.
Sir, hello, sir.
Yes, sir.
Thank you,
Please, where can you find the database toolbox?
Database what?
Toolbox.
Database toolbox.
Yeah, the toolbox database.
Up there.
I don't get you. Database what? Toolbox.
The database too. Database.
What do you want to do? Is it the relationship thing you want to see? We have database tools. It's a tab. Is it this you are talking about? Hello? The person who asked the question.
Yeah.
Is it this you were looking for?
No, like I saw somewhere like two separate something. Is it the dash bottom on the toolbox? But I don't know where that toolbox is because I know the database too, but I don't know the.
I also don't know what you are talking about. I don't know. I don't even understand your question. So maybe you go and find. You are not too sure of the question. Go and be sure about it. Then in our next class, you can ask your question more specifically. Okay.
Okay. But please, can you also enlighten us on like the two parts of the query design view?
Here. Is it this one you are talking about? Hello, the person who asked the question. Is this the view you are talking about?
Yeah, like I saw somewhere that we have two parts, the upper and the lower part, and they were saying the upper consists of some elements in the lower part. So I want you to like distinguish it.
Okay. So can you see what is on the screen? Can you see the upper part and the lower part yourself?
Yes.
Okay. And can you see what is inside the upper part yourself?
Yes.
Can you see what is contained in the lower part by yourself?
Yes, please.
So that is the answer to the question you saw. And everything I have said here, everything we have done here, this is where the tables that you can pick your fields from, they all they are located in the upper part. And of course you can click here to show all the tables that you can drop in the upper part. Then when the fields that you pick from the tables, they drop into the lower part. That is what will form your report. And this is where you can build your criteria and other things. So I was expecting that as we are doing, they are answering your question. I don't need to say that this question, this is the answer. This question, this is the answer. Yeah.
Thank you.
Okay. Okay, so that's it. That's good. Thank you for that question. Any other question, please? Okay, if no question, then the last thing I'll say is that
When are you going to get the last the recorded version for the last lecture because you don't have it?
the last one before this current one, right?
Yes, please.
Is on my machine. I'm just looking for the time to do the uploading. The uploading takes some time. No, I've not even rendered it. So give me some time. Maybe tomorrow I'll do that job. Okay. I think that lecture was a simple lecture on entity relationship diagram.
Yes.
Yeah, I'm not too much in a haste to upload it because I have already embedded some nice videos on that concept already. Have you made use of it?
Yeah.
But I'll do what you are saying. So I'll add the one we did together. I'll add it so you can add it to what I have put there.
Okay.
Yeah, so I'll do that one plus this current one. Okay.
Thank you very much.
Okay. Thank you. Too.
Thank you.
Please, when are you meeting? Are you meeting tomorrow?
Tomorrow is Thursday.
Yeah.
Yes, please.
Maybe we'll meet tomorrow. But prepare yourself for Excel. So you have to be reading around Excel. Okay, so we have actually ended Access. It's just the tutorial part.
All right. Thank you, sir.
Thank you too.
Thank you, sir.